All right, we are now ready to practice with our intro and elim rules for Chapter 8 in combination with the rules that we learned in Chapter 6. Remember, however, that our strategic approaches in Chapter 8 are created by the intro rules for the conditional and the biconditional. So while we think of conditional elimination and biconditional elimination as tactics, that is, when we see a conditional, our thought should be to eliminate the conditional by way of affirming the antecedent to bring down the consequent, or in the case of biconditional, to affirm one side or the other in order to bring down the relevant side. Here, in terms of the strategies that we've been talking about, the focus is going to be on looking at setting up a structuring subproof that will provide a blueprint or roadmap from the premises to the conclusion. So you'll see on the left side, I'm circling the premises right now, an argument that consists of the following elements. The premises, if A then B, and either C or not A, and the conclusion, if A then both B and C. So the strategy is this: when you look at what you're given and the goal or the conclusion of the argument is a conditional, your strategy is going to be set up conditional introduction, where the assumptive step is the antecedent, in this case A, and the conclusion of the subproof is the consequent of the conditional, in this case B conjunction C. Once we achieve that consequent, we exit the subproof and assert on the horizontal what we've just proven on the vertical, namely, I've just proven that if I have A, then I have both B and C. So it should be the case, once you've set up your structuring subproof, that when you then consider your premises, you see a way forward. In other words, you can start working on tactics and, where relevant, on nested subproofs, which are also strategic. So in this case, I hope you notice when you've made the assumption A, that what you've just said is that you're assuming you have the antecedent to line 1, which allows you to break apart, dismantle the conditional, and conclude B. So if you look at your conditional elimination rule, you'll see that a conditional's antecedent, when affirmed, yields the consequent. Now, what you could have done if you wanted is to work more strategically before working tactically. In other words, you could set up disjunction elimination. So let me show you what I mean by that. You could have, if you wanted, done the following. You could say, all right, given that my conclusion is a conjunction, and given that in my premises there is no built-in conjunction of B and C, I'm going to have to earn or infer B and C so that I can conjoin them. So working backwards, if somewhere in my proof I have B, if somewhere in my proof I have C, I can then conjoin them to say B and C. So then the question becomes, well, how do I get B on its own? How do I get C on its own? Well, in order to get B on its own, I eliminate the conditional at line 1 by lines 1 and 3, which we already discussed. Alternatively, what I can do, however, is knowing that I'm going to need to construct a nested subproof, that is a disjunction elimination subproof, maybe what I do is I set that up first. So, for example, when you say, well, in order for me to get C so that I can conjoin B and C, I'm going to need to generate some sort of a contradiction by way of this disjunction elimination. And so then you might say, well, what I'm going to do is before I eliminate the conditional, I'm going to assume C. What do I want? I want the conclusion of the conditional intro subproof. So I want B conjunction C. Then immediately, I go to negation A. What do I want? B conjunction C, so that I can get out of the nested subproof. I can exit it and say, from my disjunction at line 2 and then my 2 disjunction elimination subproofs, I've proven B conjunction C. So that's another way to go. You set up your structuring subproof at line 3, which terminates or concludes or completes with the sentence B conjunction C, so that you get out and say, okay, I've proven that I can introduce a conditional by assuming the antecedent and deriving the consequent. So again, there are a couple, once you've set up the structuring subproof, there are a couple of ways that you can go. So let's go ahead and finish what we've started here, and then we can back out of this version of the proof, and we can start not just start, but once we've structured the proof, we can start within the subproof in the way that I had first articulated, which is eliminating the conditional. So I have C. There's no way for me to get B on its own except to eliminate the conditional at line 1 by affirming the antecedent at line 3, right? So I thereby get B by conditional elimination. Then at line 6, I conjoin 4 and 5. I introduce or assemble the conjunction. So I've now got one side of my disjunction elimination from line 2. I immediately move on to the other side, and I notice that there's no way, given not A and given A then B, that I'm going to be able to create the conjunction of B and C out of respectively B and C. But what I do notice is that A and not A are contradictories, so I assert that contradiction. That is, more specifically, I introduce the contradiction rule. Then, from a contradiction, anything follows. The rule for that, as you know, is contradiction elimination. And now I'm out of my nested subproof, which is the disjunction elimination sequence. I'm on my I'm back on the structuring subproof begun at line 3. I justify B conjunction C by conditional elim. And then I'm out of my structuring subproof because I've just proven from the assumption of A, if A, it follows I have B conjunction C, which is our conditional intro rule. Let me go ahead and verify. Let me go ahead and make the font size a bit smaller so we get the entirety of the proof in a single window, and everything checks out, right? So remember how we worked. We worked backward from our conclusion. We assumed the antecedent at line 3, derived the consequent at line 10, so that we can say if A, then B and C. Once we were in that structuring subproof, we thought about how we're going to generate B conjunction C, knowing that there's a disjunction at line 2 that is eliminated only by the disjunction elimination rule. So we set up the assumption C, then the assumption not A, from each of which we inferred B conjunction C. All right, so now let me go back to the way that we originally were thinking about proceeding, and that is as follows. Once I have the assumption A, I said, oh, I can infer B, right? If A, then B, A, therefore B. I've got my conditional elimination justification, but I still need to generate C in order to conjoin B and C. How do I do that? Well, remember this, you will always use every line given or derived until you get to your conclusion. So I've used 1 and 3. I will use 4, but I haven't used 2 yet. So now I'm forced to assume C. What is it that I want? Well, I want C so that I can get out of my disjunction elimination subproof and assert C, thereby allowing for the conjunction intro of line 4 and line whatever C, whatever the line number is that C appears on, right? So let me back out of this real quick and approach the same thing from another direction. I have B. I want C so that I can conjoin B. Oops, sorry. I'm at the wrong line. I want C so that I can conjoin B and C, and then get out onto the main, back out onto the main line, the main spine, which now is represented by line 7, right? So the question is, well, how am I going to earn C? Well, I know that, as I mentioned before, that I'm going to have to use line 2. So if I assume C, and I reiterate C, I've inferred C from one side of the disjunction. I can exit that assumptive proof, start the second part of the disjunction elimination subproof sequence, assume not A. What do I want? I want C so that I can get out and say from either side of the disjunction at line 2, I have, by 2 successive subproofs, concluded C, disjunction elimination. Now the question is, how do I get C from the assumption not A when C doesn't appear anywhere but in the disjunction at line 2? Well, we return to what we've already established in another version of this proof as a way forward. A and not A are contradictories. So I introduce the contradiction. Then from a contradiction, anything follows. So what is it that I want to follow? What do I need? I need C. So at line 9, I assert C as an elimination of the contradiction at line 8. And we can verify, and we will get, we get a question mark and an X. The X is here because there is a missing citation and justification, which is what this question mark represents. So let's get our slider back up to line 6. Remember what line 6, rephrase. Remember how line 6 is justified. It is a reiteration of line 5. So verify again, and we're good to go. One of the nice things about Fitch is that you get feedback as you go, right? You can check individual steps, or you can verify a whole proof. And if you've missed something or you've made an error, you'll get some feedback about that. All right, so I hope that these two versions of the conditional elim are helpful in thinking through the strategy of conditional elim. Or sorry, I said conditional elim. I meant to say conditional intro as you're structuring subproof. But what if you did something like this? What if you said, oh, I see that my conclusion is a conditional, but I'm a really big fan of disjunction elimination. So what I'm going to do is structure my proof according to disjunction elimination. I'm going to assume the left side of the disjunction, and then from that I am going to get my A conditional B conjunction C conclusion. And then from not A, from the right side of the disjunction, I'm going to do the same, namely derive my conclusion, which is A conditional B conjunction C, so that I can get out of my structuring subproof and say, look, I've just proven that from this disjunction at line 2 and the two successive subproofs, assuming C and assuming not A, I've concluded if A, then B, and C. So in either case, whether I have C or I have not A, I get A, then B, and C. So that would be a disjunction elim structuring subproof. Now you can probably imagine that things are going to be a little bit more complicated here, because you still have to create your conditional in each case, right? So if we go ahead and delete a couple steps, we know that we still have to assume A, derive B conjunction C, so that we can get out and say by conditional intro, I have A conditional B conjunction C. Same thing here on the other side of the disjunctional limb. I'm going to need to assume A and derive B conjunction C, so that I can get out, exit the nested subproof and say I've just introduced I've just proven B conjunction C from the assumption A. So if I have A, I have B and C. So it's a little bit more complicated, but it's still doable, right? On the assumption that I have A, since I have A then B, it follows I have B. And since I have B and I've assumed I've assumed C, it follows I have B and C. Moreover, moving on to the other fill in the blank, I've assumed not A, I've assumed A, they're contradictory. Therefore, from a contradiction, anything follows. And then I'm back out onto, in this case, the second part of the two-part original structuring subproofs. So let's fill in the blanks here. We have our conditional intro. B conjunction C at line 11 is the elimination of the contradiction. From a contradiction, anything follows. The contradiction was generated by not A and A. Remember, we never justify. We can't justify our assumptions precisely because they're assumptions. But on a practical note, Fitch won't allow you to do it, so that's a helpful way to learn. You cannot justify your assumptions within the argument that you're given. Then B and C are B and C is achieved by lines 3 and 5, conjunction intro. B is achieved by 1 and 4, conditional elim. And let's check things out. And once again, we have a check mark. So, holy moly, we've derived our conclusion in several different ways. Two versions of the argument structured by conditional intro, and a version structured by the disjunction elimination. All right, so let's move on to another exercise. Here again, let's look at what we're given. We've got a biconditional at line 1. We know we're going to need to break that up, right? We're going to dismantle. Remember, our proofs, our derivations, are exercises in assembling and disassembling connectives. So we're going to disassemble. We're going to disassemble this conditional. We're going to disassemble this conditional. How are we going to do that, though? Well, look at our conclusion. Our conclusion is a biconditional. So that tells us our strategy is biconditional intro. Assume R, at some point derive H, exit the subproof, begin the second subproof in the sequence, assume H, derive R, so that we exit and say, we've just proven that if we have R, we have H, and if we have H, we have R. So we have we have R if and only if we have H. In other words, we have both or neither. In other words, if R then H, and if H then R, which is truth functionally equivalent to R if and only if H, that is R biconditional H. All right, so we've set up our structure. We've used the strategy biconditional intro to set up our argument, our derivation, our proof. And just so that we remember how we've set things up, I've highlighted our structuring successive subproofs and asserted the rule that will justify the conclusion. Now I'm going to move my cursor up to the blank spaces, the first blank space, and we'll fill in more as we need to. All right, take a look at line 2. Line 2 says R arrow S. Line 4 says R. So S, right? If R then S, it is R. So by the elimination of the conditional, it's S. What do we want? We want to get H. We can't pull H from line 3. That would be an invalid inference. If we were to say we had G, we couldn't infer H from G validly. Moreover, we can't just pull H off of the left side of the conditional. That's not a legal move. However, if we look at line 1, we'll notice that H is nested deep within this biconditional claim. If we get R and S together, if we conjoin R and S, we eliminate the biconditional, we pull G and H down, and from G and H, we infer H. So let's do it. So from line 5, we're going to make an inference, R conjunction S, from lines 4 and 5. And the rule is the assembling of the conjunction, which is conjunction intro. We need to make another inference now from lines 1 and 6 to 7, which is G conjunction H, right? Take a look at 1, 6, and your biconditional elimination rule. I'm hovering there so that you can see it. Oh, it's popping up to the right. But take a look at your biconditional intro or biconditional elim rule, and you'll see that you dismantle the biconditional by affirming the left or the right side of it. We affirm the left side, so we derive the right. And then from line 7, we get H by way of dismantling the conjunction, right? So the conjunction is dismantled by conjunction elimination. We pull H down. Now we're ready to work the second side of our biconditional intro subproof. Let me make the font size a bit smaller so that we can see everything on a single screen. Right, so remember, if you're still getting comfortable with the rule form, write the rule form down on a piece of paper, or if you're given a rule sheet, use the rule sheet. I give my classes a rule sheet so that you can go back and forth between the proof you're working on and the rule. You can look in the textbook. I think it's page 578 and following, where the rules are laid out. Have your textbook right in front of you. Or if you've got the digital copy of the textbook, go to the relevant page. I think, again, it's 578 to get to have that visual in front of you of the rules. And you'll see that we are working through biconditional intro. We've just completed 1/2 or part 1 of the 2-part or series of successive subproofs. Now we are working on the second half. Take a moment to notice, by the way, as we're moving forward and as you're working forward on your own, that when we work with 2 successive subproof sequences, and what I mean by that is when we work with disjunction elimination or biconditional introduction, our 2 successive sequences typically involve mirror subproofs. In other words, what we do in one subproof of the 2 subproof sequence, we typically do in the other. So bear that in mind as we go forward. We have H. What have we not used yet? Well, take a look at line 3. H arrow G. H affirms the antecedent, so we derive G, right? If H, then G. It is H, so it's G. We've got conditional elimination. And remember, the rule should pop up to your right, but because to the right of the drop-down menu, but because I've pushed Fitch far over to the right-hand side of my screen, it's covered. But you can always see the rule form there as well. So conditional elim. Now I'm going to need to generate G and H so that I can dismantle line 1 yet again to get R and S, so that I can dismantle R and S to get R. So I'm going to assemble G and H, And how do I know that I want to do that? Well, remember, working backward, we know we want R, right? Similarly to not being able to pull H off the arrow at line 3, we can't pull R off the arrow at line 2. We're going to need to dismantle the conjunction at line 1 once we have pulled the left side of the biconditional down. So we can't just reach up into line 1 right now to infer R. That's because right now the connective that governs the sentence is the biconditional. So in order to reach R, we have to dismantle the biconditional and then dismantle the conjunction. Remember, you're always reaching up into your proof sequence and you are dismantling or assembling. So we've assembled G and H. Now we're in a position to dismantle R conjunction S. So 1 and 11 by conditional elimination gets you R and S, and then R is achieved, is derived by way of conjunction elimination. And then we're done with the second half of our proof. Now let me go, let's make the font a little bit smaller. There we go. Now we can see everything all at once. Now let's work backward once again. We wanted the biconditional. We set up biconditional intro. We eliminated the conjunction at line 12 to achieve R. We eliminated the biconditional at line 1 by affirming the right side at line 11. We established the right side of the biconditional at line 11 by conjoining lines 9 and 10, conjunction intro. And we achieved the end of the first subproof sequence in as I say, in a way that mirrors, or that was mirrored by the second subproof sequence. So we have conjunction elim, biconditional elim, conjunction intro. And everything checks out. All right, let's grab one more actually, argument to work through. Here we have two premises, the main connective of which, let me get the step numbers going, the main connective of each of which, I should say, is the conditional, right? So we've got conditional, conditional. The sub-connective at line 1 is the conjunction. The sub-connective at line 2 is the disjunction. Let's also note that since the conditional is the main connective of each, we're going to want to dismantle it, which means that we're going to want to infer L conjunction S. We're going to want to generate the disjunction, which is the antecedent of line 2. Next, let's look at our conclusion. Our conclusion is a conditional. So our strategy should pop out at us. It should jump out at us. Let us set up conditional intro. Assume the antecedent of the conclusion, derive the consequent of the conclusion, exit the subproof so that we can affirm on the horizontal what we just proved on the vertical, namely, if I have not P, then I have not R. So we're setting up conditional intro. And I want to draw your attention to the structuring subproofs conclusion. Let's keep working backward. We want to achieve not are. Not are is a literal. It's a negated atomic sentence. We know from our strategies discussed in Chapter 6 that when you want to achieve a negated sentence, you set up negation intro. So we're going to assume are. We want to generate a contradiction, exit the nested subproof so that we can introduce the negation, which is to say we can say that our assumption that R is true is not the case. In other words, R is false, not R is true. Right? So our structuring subproof is a negated sentence. We're going to achieve the negated sentence by assuming that the negated sentence is false. In other words, assuming the affirmed sentence R is true. And we're going to, from that, generate a contradiction. So notice what we've done by continuing to work backward very explicitly. Namely, we've pretty much got the everything we need to now fill in the blanks. What do I mean by that? Well, notice that line 1 is a conditional. Line 4 is an affirmation of the antecedent of that conditional, which implies the consequent. Conditional elimination. Moreover, since we have L conjunction S, and we want to achieve a disjunction so that we can dismantle the conditional at line 2, we can see our way forward to that. Dismantle the conjunction elimination from line 5 to line 6. Disjunction introduction from line 6 to line 7, so that we have created the antecedent of line 2. Why do we want to do that? So introduction of the disjunction. Why do we want the antecedent? Well, we want the antecedent because by eliminating the conditional, by pulling down the consequent, we have got everything we need for our contradiction. So lines 2, 7, conditional elimination yields 8. Now take a look at line 8. P. What was our original structuring subproof assumption? Not P. These contradict each other. And once we achieve the contradiction, we exit the negation intro subproof. And once we exit the negation intro subproof, we're now back out onto the structuring sequence started at line 3. Let me go ahead and make the font size smaller so that we can get the entire proof into a single window. So take a look at 4 through 9. 10 is negation intro. Take a look at 3 through 11, and we have conditional intro. Let me go ahead, and I thought I had asserted the contradiction intro rule. Right, so the more you can work backward from your conclusion, whether it's the conclusion of the argument or a subproof conclusion, the more work you'll get done in terms of laying out as robust a blueprint as possible for your derivation. So let's go ahead and check everything out. We've got an X. Why do we have an X at line 8? Because I introduced the wrong sentence. So did you see that? I introduced S because I wasn't clear about what I was writing. Now, you're watching this video. You've probably been screaming at your screen the whole time. Mia, you introduced the wrong sentence, and you were right. Now, what's great about that, if in fact you did that, is that means that you don't need me to tell you what to do. When you know the rules, you've got the machinery of the system, you don't need anybody to help you along. If we were face-to-face in class, I would expect you to have screamed, Mia, you wrote the wrong sentence at line 11. All right, so we've got now the correct sentence. We can check everything out. Yay, we're good to go. All right, I hope that this practice set has been helpful to you in thinking about how to use your conditional and biconditional intro rules to structure your subproofs, as well as how you can use nested subproofs to further flesh out your derivation blueprint.